Okay, now over to this other type of isomerism called stereoisomerism. Now, what is stereoisomerism? Stereoisomerism is the existence of isomers. The existence of isomers with different spatial spatial orientation. Okay, with this different spatial orientation of atoms or group of atoms about a C to C double bond, that is carbon to carbon double bond, or a ring structure, okay, or a carbon attached to 4 different functional groups. Now, each of these arrangements, each of these spatial arrangement of atoms, each of them are called what? A stereoisomer. That is what we mean by stereoisomerism. It consists of 2 types, which is geometric and optical. Geometric isomerism and optical isomerism. Okay, so in geometric isomerism, look at the example here. Like, take for instance, we have something like this. First of all, let me put the double bond. So let's say we have here CH3, we have here C2H5, or let me just break it down to CH2, CH3, C2H5. Now we have here hydrogen, we have here hydrogen. So this is a geometric isomer. Okay, this is a geometric isomer. Now, if you watch, these 2 groups, they are attached groups. Okay, they are at the opposite sides of what? This C to C bond. Okay, now let's have another isomer. If you want to have another isomer, it means that this one, let me just draw it again. This is C. So in this other isomer, this one now will come up. C2, CH2, CH3. This one will be up and the H will be down. And this one is already up, CH3, and the H will be down. Now, this is another isomer of it. Okay? This is another isomer of it. This one. Look at it here. So, this one is this is a trans isomer. This one is what? A cis isomer. In the trans isomer, the attached group, they are on different sides of the C to C bond. While in the cis isomer, the attached group, they are on the same side of the bond. Now, this molecule is this one. Let me name this one. This is this is trans 2-pentene. Okay, yeah, if you count the number of carbon atoms, 1, 2, 3, 4, 5. Okay, this is trans 2-pentene. Now this one is cis 2-pentene. Cis 2-pentene. So this is an example of a geometric isomer. You see this double bond there? It restricts rotation. This double bond, that is, it prevents free rotation of this attached group. You understand? So it's unlike structural like in structural isomerism, where they will be forming branched, they will just be free to rotate anyhow they like. No, it doesn't happen here. This one restricts free rotation. So either they are on the same side, which we arise to cis form, or at different sides, which we arise to what? Transform. That's how they are. They exist in cis and trans forms. In fact, geometric isomer, another name for it is cis and trans isomer. Another name for geometric isomerism, cis and trans isomerism. So this isomerism can also happen in a ring structure like this. In a ring structure like this is an example of a ring structure. You know, all these cycloalkanes, it can exist there because this ring structure also prevents free rotation. It can also occur here. So whenever you see this, you know you are dealing with what? Geometric isomerism, which exists in cis and trans forms. Now, in my next video, we talk about optical isomerism. Okay, that one involves just one carbon atom being bonded by 4 different functional groups. The carbon atom that is being bonded by 4 different functional groups, that particular carbon atom is called the Scherer center. That will be what I will consider in my next video. That one I will draw something that will help us to understand optical isomerism better. Okay, let's leave it for now.